What's up, guys? How you doing? I just have a question. Have you ever wondered if you could make your own anvil? Well, I have, and I've thought for a long time, what if you could just weld a bunch of plates together that are cut off your plasma table and grind it down? Would that be a decent anvil? So today's episode, we're going to test a DIY anvil. I created a file. It'll be available on the website if you guys want to try this yourself. It's 9 plates. I designed it out of 5/16 because that's what I had in the shop. But if you cut it out a 1/4 inch, it'll work just fine as well. Basically, the idea is we take these 3 plates, make up the center, and then we slowly graduate out to the edges. So we can make a 3D shape using 2D flat patterns by merging all these together. So this is the big idea right here. There's our anvil. You want an anvil to be really hard. The test that I looked up is dropping a 1-inch ball bearing, and you're looking for how much rebound it has. So a good anvil will have something like 90% rebound, which is almost unbelievable. That's crazy. A cheap anvil will have somewhere around like 30% rebound. So I'm really hoping we can get like a middle of the road result out of this anvil right here that we're gonna make. So in order to get a really nice hard top surface, because mainly you're gonna be beating right up here on the top and then this horn as well. So all these top surfaces are gonna see most of the action. I'm gonna bevel them all the way down, so in between the plates, we get lots of penetration and filled up with nice cohesive weld puddle where everything can flow together. And then we'll grind that all flush and see where we're at basically. If that doesn't work, I've got a couple other ideas, basically using some hard-facing stick electrode, or even buying a piece of cold-rolled tool steel. Okay, and then I could just maybe weld a plate, like a 1/2 inch or maybe 3/4 inch of tool steel right to the top of this right here, and that should give you like a really nice solid bounce. So that's the plan. Let's get rolling. You guys want to see beveled each side of these right here? So it should give me a little more penetration is the idea. Alright guys, I'm going to run this thing super hot because I'm trying to get as much fusion together as possible. I'm at 29 volts, 510 inches a minute, and I'm pushing an 030 70 series wire with 75-25 gas mix for shielding. Pretty much, you just want to pour as much heat into this thing as possible is my theory right now, because I'm trying to create a nice cohesive block of steel at the end of all this. So I got everything lined up how I like it. Time to start burning. Alright, let me show you guys what I'm working with here. I lost gas coverage right here. There's a little porosity. And then again right here at the beginning of this weld. So I'm going to go ahead and grind those 2 spots out and fill them back up with some nice solid metal. Also, if you notice where I got started over here, it was a little cold. Things hadn't quite preheated yet. So I had some cold roll over here. But once everything got warmed up, you see by this like 3rd pass, everything starts sitting a lot flatter. You know, showing that we got good penetration in here. So as soon as I fix these spots, I'm going to start working my way around. over here and filling in these sides and kind of stepping them forward a little bit, trying to fill that up so we end up with a nice solid mass up here on the front. So I'm gonna keep cooking. Alright guys, at this point, I've got it all welded up. Looks like a big mess, but I burned everything in really hot. I basically stepped my welds down to try and even up that slope and get rid of that stair-stepping effect down the side. I think that's going to make it easier for me to round all this over to make this horn on the front. Then, didn't totally weld the whole thing out, but I did weld this bottom up right here just to try and make sure everything stays tied together. I'm gonna grind this down like this and kind of see where we're at with rebound. Alright guys, here is the anvil. I already snuck it over to the belt sander and kind of flattened the top up as best I could. Really the test is a 1-inch ball bearing from 10 inches up. You're trying to see what kind of bounce this thing has. So just as kind of a frame of reference, our fab table's here in the middle of a cell. No bounce at all. If you get right over one of the tabs where you weld, you get a little bit of a bounce. Come over here to a corner, and you get a little tiny bounce, but not much. Really, before we go and test this, let's go kind of show you the bounce on a couple other things around the shop. This is not very scientific, but it's kind of fun. I never really thought about this. Arbor plate on our H-frame press. Well, woo. Yeah, don't lose these things. Good luck. It's actually got a pretty decent bounce to it. Just a piece of cast iron. Could try the bed in our finger brake here. This should be tool steel. Ooh, that's got a pretty decent bounce to it. Alright, that might be something like what we're looking for. Then we come over here, some more tool steel on our bridge port. See, and this has a pretty decent bounce. Then we have the bed, this old school bed of our joiner, this big old cast iron base. If we drop the ball right over where one of these bolts hooks up, we get a pretty decent bounce. So, not super scientific. Try the concrete. So now, alright, so you kind of saw how much bounce we got off of some regular stuff here in the shop. We made this specifically for bounciness, is the big idea with anvils. So we need to set up a test. Basically, we need to drop this 1-inch ball 10 inches, or from 10 inches high, and measure how much it rebounds back up, and that'll give us a pretty easy percentage based on how far it bounces back on the tape. So I'm gonna try and set up a little experiment here. This gives us a good baseline to check. The next process we're gonna do here is we're actually gonna load up some of this ultra hard facing stick rod electrode, the big stuff. Pump impellers for gravel and sand, shells, buckets, loader lips, conveyor screws, pug mills, mixer chutes, blades, bulldozer bits, snowplow shoes, cinder and slag handling equipment. This is the hard stuff. I know that this is used for repairing anvils, so I'm kind of hoping that I can put a nice hot layer down right here and harden up the top of this, because let's take a look. If you see these little dents right here? So those are dents just from dropping that 1-inch ball bearing. Those are the little spots. So this is still pretty soft steel, and I just don't think it's going to hold up very long as an anvil with just regular old filler rod. So that's why we're going to this, but this takes the stick welder. So we got to go outside and hook it up on the blazer.